Hello, this is Bradley Needham. I will be talking about 4 iterator helper functions that are part of the STL, 2 of which were introduced with C++11, Next, and Previous. These helper functions provide some of the capabilities of random access iterators to other categories of iterators. Example, the ability to advance more than one element at a time or calculate the difference between 2 iterators. I've included the header files that I'll need for this example, including iterator. That's where these helper functions exist. Let's start with advance. I'm going to create a forward list of integers. This will be my collection 1. I'm going to provide some values for it. And then let's say I'm going to print out the first element through an iterator. So I'm going to get the first iterator, which happens to be the beginning element of that forward list. And then I'm just going to print out its value. All right. And I run that, compile and run it, and of course I get the value 1, which is the first element here. Now let's say I want to go to 4 elements beyond the beginning, 1, 2, 3, 4, to the value 9. How would I do that? Well, this is a forward list, which means it only provides a forward iterator. What I might try and do is something like iterator plus equal 4. Well, that's not going to work. It's going to give me a compile time error. Since this is a forward iterator and not a random access iterator, it doesn't supply the plus equal operator on it. So I can't use this. Now, of course, if I change this to a vector, this would work fine. I wouldn't get the compile error, and I could actually print out the new value of iterator 1, which should be 9. I get that 1 and 9. But with a forward only iterator, from a forward list, I've got to fix this. And the only way I can do that is to walk over each element the number of times that I want to move the iterator. Now I should get the same value out here. So there's my 1, my initial value, and then using a loop I still get 9. And if I change this back to vector, this still works. However, this works very inefficiently for vector. This is the way I have to do it for a forward list, but it's very inefficient for vector. I should be using a plus equal in this case. So, a couple of advantages now to the advance function. So the advance function will move the iterator just like we are through this loop here, the number of spaces that we request. I should still get the correct value here, whether I'm using a vector or a forward list. Both these should work. So using advance again now here. But there's a couple advantages here. One is that this is clear what I'm trying to do. Whereas if I was using the for loop, having a raw loop in here like so, a maintenance programmer has to look at that and go, well, what is he trying to do? Now I could have a comment up here that said advancing the iterator, by 4. All right, but again, that's not quite as clean as being able to simply say advance the iterator by 4 elements. Okay? So that's one advantage. One advantage of using advance. The other advantage is that with that loop, right, when I switched back and forth between a vector or a forward list, when I was using a vector, it was going to be slow. When I was using forward list, it was going to be slow, but it was the only way that I could actually do it, right? So I want to use the most efficient way of advancing between a vector or forward list. By using this advance function, it can determine what type of iterator this is, whether this iterator happens to be a random access iterator or whether it happens to be a forward-only iterator. And in that case, it can decide what implementation it needs to use. Does it need to loop, or can it basically just use a constant expression, as in the case of vector or random access iterator? So in this case, this is as efficient. Advance is as efficient as saying it1 plus equal 4. Okay? So that's why we might want to use advance. Now, some reasons why we don't really like advance. One reason we don't like advance is that it's changing this iterator. So I have to create a temporary iterator that I can use to pass and be manipulated in here. Now, the other reason I might not like it is that I can't make it part of a larger expression. And by that I mean I couldn't just simply say, using advance here, and just go ahead and advance the iterator and dereference the result. And the reason why is because advance returns void, so you can't leave it as part of a larger expression. Well, that's why in C++11 there's been introduced two new functions, and one of those is next. So instead of using advance, I'd much prefer to use next. Now, the difference here in next is not going to manipulate this iterator. So if I just replace my calls to advance with next, I'm not going to get the results that I'm looking for, right? It's going to come back and say, here's my initial value, and then here's the value that was advanced to. Well, it didn't really do anything. It didn't change that iterator that was passed in. So iterator 1 remains the same through all these function calls. Well, this is because because next actually returns you an iterator. So I could put in auto iterator 2 equals next here, and then I could, instead of printing out iterator 1, I can print out iterator 2. Right. So there it is, using advance, this iterator, it's advanced it and it's moved it to 9. Or, like I said, since it returns that value, I can simply place it into this part of the larger expression here, not having to create another temporary for that, and print it out, and again it correctly gives me the value of 9. And this is, sorry, I've got to change this to using next. Okay, another thing, a little quirky thing about advance is when I advance something, I can actually advance it a negative number. So let's say we start here at the end of the collection, and then let's advance this iterator. Instead of 4 spaces forward, let's advance it 4 spaces back. Iterator 1. So when I advance it with a negative number, I get 8 here, because I walked backwards from the end. Here's the end, it's just right one past the end. 1, 2, 3, 4 spaces back, I get the value 8. Well, that's all fine and dandy for a vector, because a vector is a random access iterator, which means it can go both backwards and forward. Also, if I put a list in here, it should also work, right? Again, because a list provides a bidirectional iterator, which means I can go both forward and backwards. But what happens if I pass a forward list? If I pass a forward list here, bad things are going to happen. So I run it, it compiles fine, and then when I execute it, I get a runtime error of a bad access because I'm trying to access a piece of memory that doesn't work with this iterator, right? You're going backwards here, and you cannot go backwards on a forward-only iterator. Well, this is a problem mainly because we don't like to have runtime errors, right? Runtime errors are bad. Compile time errors are much better because you're the only one that gets to see your compile time errors. So, what do we do here? Well, we knew that there's the new next function, which was replacing advance. Well, there's also a previous function. And the advantage of previous is, of course, when you used advance here, and put advanced back here, advance, we were talking earlier about it being, maintenance-wise, it's easier for somebody to understand looking at advanced. Well, this is a little more difficult. Somebody says, oh, here's advance. I'm advancing something, but I'm advancing at a negative number. That's not really advancing it. That's really going backwards. It's going to the previous elements. So that's why in C++11 they also added in a previous function. So we have previous. Instead of using advance negatively, we can say previous 4 elements. previous like next does not change the iterator passed into it. Instead, it returns a new iterator that will point to the value that you're looking for. So I'm going to print a new auto variable iterator 2. It'll get the previous element, and we'll change this to using previous, and I'll change that to iterator 2. It's passing in. Now let me go back here, and so here's something that we find interesting now, is that instead of just compiling like it did before when I was using advance with a negative number, since I'm using previous is going to determine, hey, wait a minute, you just passed me a forward iterator. Sorry, I can't work with a forward iterator because I'm supposed to be going backwards through the collection. So if I look at this error here that is coming up from the compiler is going to tell me basically, hey, there's no matching function called to previous. There doesn't exist a function called previous that takes a forward iterator. So all I have to do here is, again, this is great because it gives me a compile time error, so I can go, oh, that's right, I can't go backwards through a forward list, and then I can go back and change it to a list, and look, the error goes away, and I can run it, and it gives me that value using previous. Or I can go ahead and change it to a vector, which of course is also a random access, which supports forward and backwards traversal as well, and I can use previous. And again, previous, like next, like advance, are all smart enough to realize the type of the iterator so that it uses the most efficient implementation, whether that be a loop or whether that be a constant expression like plus equal 4 or minus equal 4 in this case. Okay? All right, so the last thing I'm going to talk about is the function distance. And distance, again, just gives you the distance between two iterators. One thing you have to be aware of with distance is that the second iterator passed to distance function has to be reachable from the first iterator. And what do I mean by that? So if I say I'm going to print out the distance from my beginning iterator to, let's say iterator 2, the beginning iterator is going to start right here at element 1, right? And we know that iterator 2 here actually equals element 8. So in a forward direction, right, this is reachable. So basically the distance can calculate the actual elements that will be traversed. And how many we got? 1, 2, 3, 4, 5. So we should get 5 out as our distance. Let's run it. So using previous is 8, and the distance is equal to 5. Okay, thank you, and I hope this helps.